Hey everybody, so in this video I'm going to be talking about impedance in circuits. So to begin with, let's take a look at the definition of impedance means to prevent or delay or to slow down the progress of something. So when you see impedance, you could think of a resistor. Okay, so you have the wire and then, all right, let me change the color. So you have a wire and then here's the resistor. Okay, so you have current flowing through and then within the resistor, okay, it's slowing down, it's delaying the progress of the impedance. So that's what you should think about when you see impedance. We're slowing down the progress of something. And in impedance in circuits, okay, you have the units of ohms. All right. And there are three major components in impedance, especially when you use AC analysis. So we have in DC analysis, we only have the only impeding component is a resistor. Okay, and then in AC analysis, we have a resistor, okay, an inductor, and a capacitor. Right? I have written down these their expressions uh, in AC analysis. So for an inductor, its expression is J omega L. Okay, so what the J means is that we're dealing with complex numbers. So remember when you have right here the x-axis is your real axis, and then the y-axis would be your imaginary axis. So instead of using an I, we're just going to use a J. The reason is to not confuse between the I for current and I for imaginary. So we're just going to use J for imaginary. Okay, that's what the J is. And then the capacitor's expression for impedance is 1 over J omega C. Now this could also be written as J over omega C, or I should have said negative J over omega C. The reason why is because when you multiply, you could rationalize the denominator by multiplying by J and on the top and bottom. So then that would leave you with J over, okay, when you have J times J, that just gives you -1, and so you're left with a negative omega c. So we just put the negative on the numerator. And so what J is the square root of -1. Okay, so if you have the square root of 100 or -100, okay, this could also be thought of as the square root of -1 times 100. Okay, and then so you could pull out the 10 because the square root of 100 is 10, and then you're left with the square root of -1. And we know the square root of -1 in imaginary is just j, so then that would just be 10j. Okay, and then lastly, the okay, so when talking about real and imaginary, okay, real versus imaginary. Oh, yeah, I didn't spell that right. Okay, imaginary. So the resistor is always real. Okay, it's always positive and real. You're never going to see a -2 ohm resistor. So it's always positive and real. Okay, and then inductors, they're always positive and imaginary. So positive and imaginary. And capacitors are negative and imaginary. Okay, and then I want to talk about is let's say we have a circuit. Okay, we have the AC voltage being applied, and then we usually represent these impedance, whether it's a resistor or an inductor or capacitor, with boxes, and we just say what's the value of that box. So we have 4 ohms here. That means we have a resistor. If we see -3 ohm, -3j ohms, that means we have a capacitor, because we said capacitors are negative and imaginary. Inductors, okay, the inductor is positive and imaginary, and resistors are positive and real. Okay, so if you see -3j, that means, okay, we have a negative number, and j meaning it's imaginary, so that you could automatically tell that it's a capacitor. Okay, the first one is we said is a resistor, and then let's say we have right here 5j ohms, and you could tell that is an inductor. All right, and we can combine all these. So we could combine all these because they're all in series. Even if they're in parallel, you could combine them. But they're in series, so we could combine them just like how we combined resistors in series from DC analysis. So this would just end up being, we have the, let me zoom in. So we have the AC voltage, all right, and then you just end up having one box that combines all those impedance. So what we had was, okay, 4 ohms, negative 3J, 5J, combined like terms. So you'd be left with 4. Okay, let me write it outside. So 4 minus 2J, and the entire thing has units of ohms. And then let's say we want to draw the phasor diagram of this. And what this means is you have a real component and an imaginary component. The real component has a magnitude, here, I'm going to use a different color. So the real component has a magnitude of 4, and then the imaginary has a magnitude of negative 2. Okay, so that is a 2 going downwards makes it negative. So 2J, remember this is the J axis and that's the real axis. Okay, and this is 4, and then you can find the angle and then the magnitude of this hypotenuse. And I'm going to talk more about phasors in a different video. So this was just an intro to impedance, a little intuition about it in circuits.